Hello, welcome to Distributing Digital Media over RF. This is Doug Engstrom with Contemporary Research. In this webinar, we're going to explain the basic concepts of RF and how it compares with other distribution systems you might use in the facility. We're going to cover how it works, how it's distributed, how you basically design a system, how does encoding work, and how does control carry over the same system. You basically look at four concepts on distributing media over an entire facility. This is very different from trying to do this over conference rooms and boardrooms as we typically have done for media integration. The one people know the most or heard the most is video over IP or IPTV. And there you're sharing multiple MPEG packets streaming over 4 twisted pairs carrying Ethernet. And you're sharing the bandwidth of the streams with all the other data within the system. So the throttle for that application is going to first be how much bandwidth is available to be streaming something all the time or for long periods of time, and are the components capable of multicasting the packets throughout a facility. Many don't. Digital RF is very related. It as well as carrying multiple MPEG streams separated by frequency. So channels 2 through 135 are each individual MPEG streams that are being carried across the system. This is the same way you get your video from Infinity. It's the same way you get them from Dish. It's the same way you get them from DirecTV. They're all channels broadcast over wire or RF, and it gets to your house, it gets to your TV using one wire on a coax cable. And for some of you in homes who people think that digital RF is kind of a dead thing, for most people that's how you're getting your Ethernet, is Ethernet carried over the same coax cable carrying your channels. Cat5 HDTV, which is the technology that really made distributing media over Cat5 a lot more meaningful and useful and reliable. You'll have a router switcher that can send one video and data, possibly Ethernet, audio, over 4 twisted pairs, going up to 300 feet in distance, much like IP is also limited by 300 feet. IP switch video presents itself as something new, but it's kind of the same concept. You're using a 10G level 3 switch, sending a motion JPEG video stream, however they want to call it, over 4 twisted pairs up to 300 feet as well. So those two are very related. The difference is on the HDTV, it is a direct baseband video that's being carried, where IP switch video has to be IP. So motion JPEG is a technology that's free. So it's easy to incorporate in your system, and it carries video very well. That's what you see in movie theaters, a special version of that. And there are lossless versions of it that can carry the video with very low latency. There's going to be some, but generally not so much that you can notice. As you compress the signals more, when a lot more channels start happening over there, though, you will see more latency because you have to compress the videos more to get all the videos through the same switch. IPTV, I look at that as rocket science. As an integrator, you're not totally in control of your network. The IT team is, and the equipment that they have. So you need to have a switch for origination of routers and a working Ethernet system. And that has to be generated and regenerated every 300 feet. Plus it means do multicasting to send a lot of video over a system. They probably need to have greater bandwidth than they have right now because they're always riding the edge of the network bandwidth. I don't know too many companies have lots of bandwidth just left over waiting for somebody to use it. And a lot of times you need new equipment all the way through the system for multicasting because your routing switcher, basically a multicasting is making copies of the video. so that if you're all sharing the same switch, you're just seeing copies. We're not actually sending 12 copies of that through the entire network. So all of your routers and switches and hubs need to be capable of doing multicasting, copying videos, and even if the system theoretically has it, that software sometimes needs to be added or turned on, and that adds a lot of overhead, so network people are not necessarily excited about making that happen if they haven't planned on it. So when you're designing for this, your biggest limitation is working with whoever in the company is managing their IT department, how excited they are about distributing IP over their system. There really isn't too much of a system-wide control solution, though I think AMX and Crusher and others have different types of room view and room control systems that do travel over the network. The main thing to IP is that there's no clock to manage timing. So the packets are addressed to get there, but when they get there is random. So your latency will be generally high. In large stadiums, often as much as 8 seconds. And the video standards right now being used are 1080p. 4K is kind of much farther in the futures to roll out when you're talking about networks across an entire country already standardized around MPEG-4 and 1080p. And we'll talk more about that later, and I have some links on my blog about that. Cat5 video is something that most integrators, I think, are familiar with. The nice thing, again, is you're totally in control of how the system works. You're running the wires very often. The system is Crestron end-to-end, AMX end-to-end, so you're responsible over the entire system, but you have control. Though most of the systems stay within a short distance, again, limited to 300 feet. So these are not always used for facility-wide control, mainly because the switching gear is expensive and it has limited numbers of outputs. So eventually, if you're trying to talk across a whole facility, that can be a lot of outputs, and that can be a lot of inputs, often beyond what's available from the manufacturer or a routing switch. You're going to run a home run to each position. So you're not running as a network with hubs and things like that. It's a straight run of Cat5 video using either IP technology or HD-based T to carry the signal over the wires. It's expensive. The control is custom, but does some pretty amazing things. Great stuff. But if you're trying to do something economically over a facility, it's often a pretty hard technology to employ. Some systems have capability up to 4K, so that's on the horizon. Again, I have more on that, but the big deal is that the latency is low or instant on that technology. But again, cost and wiring is the big deal there. RF, in comparison, is Legos. You can exhale. It's very powerful. I can start with 1 or 2 channels, carrying, like in a church, SDI video and maybe digital signage. But I can go up to 135 channels, and each one can carry 2 programs. So you can go up to 270 programs in the system. I haven't seen one that big, but that's how powerful coax is. It's a very scalable, very powerful thing that you could never put that much programming through any kind of the other networks. But the components are simple. Splitters and taps that are a few bucks. They have no power supply. They have no components to die. They last pretty much forever. And some systems for long distribution, you might also be taking that over fiber systems, isolating building grounds, and also going long distances around a stadium facility. But your destinations and distance are long. I mean, RF is being carried over your cable system for miles all across an entire city. So distance and number of destinations isn't really a problem with RF. The neat thing is TVs have IPTV receivers built in. We call them tuners. But they find channel 2. They look and see the programs as a 2.1 and 2.2. Take your channel up, down, and you're there. So control is not tough. Most people know how to operate channel it down. But we can also do remote control over the same coax through a system that contemporary research makes, and we'll cover a little bit on that later on. We're also seeing convergence happening, not RF going to IP, but IP going to RF, because large-scale facilities, stadiums, and arenas are discovering the 8-second latency of IP is not going to cut it. The people in the skybox are on full-time instant replay. They can watch the game and then lift their heads and wait 8 seconds later and they can see the same play over again. Also, it's very expensive. So, why spend millions to show an image that looks the same when you spend thousands for RF? So, you can take the same money, and they're taking it, putting Crestron systems, AMX systems within the facilities, so it's a better fan experience outside of just TV. Latency is very low for an encoded system. Typically, you're hitting 500 to 800 milliseconds, which is much better than 8 seconds. And there are some products out there that get out to a second, second and a half. That's kind of long for a lot of people, but again, still better than IP. The standards right now take you up to 1080i. There are some standards available for 1080p, but the cable companies and the industry and the TVs had not adopted those standards up to this point. That could change at some time, but right now the benefit is there isn't a lot of change because the TVs have to be compatible with the transmitters, the modulators that are sending the signals. So the nice thing is you have a system that is agnostic for models. It's not captive. You can use our equipment, you can use somebody else's, take ours, mix it with somebody else's, use whatever brand of TV you want, and everything works because it's set by national standard. They have to work together. So one of the benefits of that, it just makes it very simple because you've got rid of the proprietary problems, the distance problems, and the control problems. The coax carries everything. So it's a nice system when you're doing distribution of that sort. You're probably not going to use it for teleconferencing or in a conference room switching video back and forth and a guy has to use a mouse. It's not that kind of network. But especially going facility-wide where latency isn't critical and cost is really important, RF does a great job. The math is really simple. You have to know how to add 3.5 to 3.5 to 3.5. That's your big math right there. So a splitter, let's say a modulator starts out, let's say 30 dB. That's how we measure signal strength, which actually is a very tiny amount of power. It's not huge. A 45 dB amplifier uses less power than a light bulb. So we're not talking about explosive energy taking place within here. We're broadcasting. So let's say if I started at 30, a two-way splitter will subtract 3.5. A two-way splitter, 7. A four-way splitter, 8-way splitter, 10.5. So the math is really simple. Taps are a marvelous piece of equipment. I really like that as a guy coming from baseband video because it's like a force multiplier. Taps are rated by the number of power they subtract to every TV output. So here we have an 8-way tap. Each one of those will subtract 20 dB. So if I started out with 30 to this, I'll have 10 dB to every TV. So I can take that run out to the TVs. 10 dB will get me a lot because we're trying to reach 0 at the other end. So I can go pretty far. And the nice thing is on the output of the tap, you have almost the same amount of power that you started with. So if I go into this tap with 30, I'll have 29 that I feed to the next tap, and 28 to the next tap, and 27 to the next tap. So huge amounts of energy are conserved, and I can power all kinds of TVs using taps in my design. The wiring itself subtracts about 3 dB per 100 foot. So if I've got that tap, I've got 10 dB coming out of it. I can go 300 foot quite easily, and I still have dBs left over to feed the TV. And usually the number of channels that you do nowadays compared to the old way of doing things, you're generally carrying a lot less channels, and so everything becomes more efficient all the way through the system. But that's the basic math. I won't get too deep in design. I'll cover it a little bit later. What's changed is that when I was working in the integration systems pre my AMX days, you didn't bother with the cable system too much. So there was a room downstairs. They had guys with suspenders and big bellies walking out of the room. And all I knew about it is that it had an RF channel in the boardroom. I plugged it into the tuner and connected it with my control system and changed channels. And that's all I needed to know. But everything's shifting now where the integrator is much more involved in how the channels are being handled than ever before. So the cable company would like to, if you look at the left side of this, they'd like to give you Ethernet, they'd like to give you on-demand video, they'd like to give 800 programs, 1,000 programs, more if you include music. And they'd love to treat you like a home where people want all that entertainment. But in the corporate world, in the houses of worship and other locations, they don't want all that stuff. Usually in a corporate center, they might want Bloomberg, the Weather Channel, CNN, Fox, to keep everything fair and balanced, and specific channels that are important to them, and they're generally distributed to public TVs and hallways and other areas, and they might also be in some of the boardrooms and other meeting rooms. And then, because they're only carrying a few channels, they can also distribute some of their in-house. So for example, WWE takes the HD SDI feed from their studios and broadcasts that as a TV channel all throughout their building. So everybody has a TV on their desktop and they can see what's coming out of the studio at any time they need to. When you get to bigger stations like Univision, they have, I think, about 50 studios, and they're outputting 50 channels. So at any time, they can see what's going on in any studio just by changing channels. They didn't need anything. That would have been impossible to do over their network. But typically, people also want digital signage. So you have a corporate information channel. A church would want SDI from the sanctuary video and maybe digital signage going out. So they don't use a lot of channels. They certainly don't want all the channels coming in by the cable system. And these are all what we call clear channels. Any TV can tune it. You don't need a cable box, DirecTV box, or anything like that. We convert those signals coming from the cable company or DirecTV into a clear QAM channel. And QAM simply means that's the standard that we use to carry the channels on each channel. And your TV is designed to tune that. So you do this channel scan, you're finding all the QAM channels in the facility, maybe a couple analog channels scattered in there. But the basic idea is the integrator is involved with that. You're putting in modulators, so they have in-house channels, and then in many cases you're also doing control. So the TV is out in the hallways and the other rooms can be turned on and the channels can be changed whenever you need that. And that's just simply be done by adding a control channel. In our technology, that sneaks in between channels 4 and 5. There's a fairly big gap there. And then you put a controller in every TVs, and you have an integrated control system going to the TVs. Again, pretty simple stuff. You didn't need any other wires, just use the coax that's already there. Now, when you build a system, you're going to take the output from like a digital signage player and feed that, say, into an HDMI input on a modulator. We have certain ones that if you have older computers with RGB, you can plug it into the RGB connector, and that'll also take a component feed as well. Plus, there's also video inputs for closed captioning information for, say, satellite boxes, or you might have an old camera or something they still want to route as video within the system, and they can do that. I'll have a blog in the other discussion on how you can use HDMI with modulators, so I get more into dealing with HDCP and different techniques. The nice thing in most of our systems, digital signage and a lot of the sources we have, HDCP, is not really involved with this. This isn't consumer stuff. This is commercial stuff. So HDMI is great though, because when you run it, the audio connections and the video connections are all together in one cable. So you run it there and you're there. SDI cables will have just a different connector on the unit, and you take the SDI feed for the camera or studio system, effects generator, plug that in, and that'll take the SDI feed, turn that into a high definition cable channel, and you can broadcast that. Often for sports bars, they're using DirecTV, and the boxes used for sports bars still have component outputs. So typically they'll take two DirecTV receivers, connect them to the two component receivers, and broadcast that as a channel, and then 2.1 and 2.2 are the two cable boxes. Then you add those up, typically about 8 to 12 channels in a sports bar. So components still alive and well and being used in this industry today. And so basically video is possible, RGB, HDMI, SDI, and component are all valid inputs you can use and convert into a digital channel. And when you put them in there, you'll give them an ID number. So just about everybody's encoder, well, if you set it for channel 2, it'll give those programs 2.1 and 2.2. You can get fancy and call it channel 22 and tell the TV, I want you to tell it, when you scan the channels, it'll show up as 22 instead of 2.1. And so you're free to actually change the number associated with each program to suit whatever you need to do. It's very flexible. Then you take the encoders and you connect them together to an amplifier or a combiner, and then output that into your system. And we use two words when you hear us talking about this. Encoder talks to the first half of the unit that is taking the video in and putting that into an MPEG stream. The modulation side takes the MPEG stream, attaches that or combines that with an RF channel, and then when the TV picks up channel 2, it picks off the MPEG stream and plays the video inside. So it's just like IPTV, but it's traveling over RF as a channel. Just like on your phone, you can watch a video on your phone. It's carried very much the same way. The little antenna out there is RF, and it's sending video as data. You pick it up on your cell phone, you can see it on your cell phone. Same concept. But we use MPEG 2 for cable QAM channels, and looks like it's going to stay. The cable companies are all staying with MPEG 2. DirecTV and Dish, it's very easy for them to shift their origination from MPEG 2 to MPEG 4, and satellite TVs don't have the bandwidth that cable has, so they went to MPEG 4 a long time ago. And all that means in MPEG is that you start with a bunch of pictures. The first picture is the only actual picture. It looks at a compressed image of that screen grab. The rest of the pictures that follow afterwards look at each other and try to figure, okay, what moved, what color changed, what stayed the same, and what's added, and that's expressed as simply data. So the only picture is the first one. We call it the iframe. All the rest of it are interactive. They look at each other and come up with the best idea of what that could be. And then when you get it to the TV, it's going to take some time, and it puts all of that back together again to give you a video that looks kind of like the original. And generally there's about 500 or so milliseconds to encode all of that. Remember, it's live. You're doing it in real time. It isn't the video stream you're playing from a server. And the TV needs about 150 milliseconds to put everything back together in its original order and show it as an image on your screen. And that's where we come up with 500 to 800 milliseconds, because the TV also adds a bit of delay to that. So it'll never be zero, because you have to encode it live and you have to decode it live. So I think in today's technology, about 500 to 800 is where most of it lies, though you'll find some products that aren't thinking about integration, so those numbers can climb up to 1 to 1.5 of delay. But in your design for churches and facility, you always have to be aware there will be delay. So don't surprise people. You know, when they got hallway TVs where the sound's going to be a problem, don't use sound. Or you might have to do SDI to those lobby TVs because you need sound that's immediately there. Or use SDI to the overflow rooms because the subwoofers can be heard in the overview room and the time delay would be obvious. So you have to include latency in your plans when you're doing design, because you're encoding and decoding, just a fact of life. When you output, generally modulators today will take 2 very high megabit streams, so like 19 megabit streams can be put into one channel, and that's where you get the 270 programs, because you have 2 channels per each unit. And some encoders can send the same streams over IP. They'll be separate. So there'll be a stream with one address in the stream with a second address sent to the network. And then if you're really looking forward to how things could change and shift in the future, what's really nice is if your encoder can also shift and do MPEG-4. And I think the IT manager really appreciate that, because right now they know they have to push the stream over RF. Their network can't handle it. But it's nice to know if their network expands, you could send the same piece of equipment and make MPEG-4 streams over the Ethernet. And we have some sites that are doing digital RF over coax, but they're also doing MPEG to TVs that do not have RF feeds to it. So they just put MPEG receiver on it, and they're seeing the same videos the people with RF TVs can have. So it makes it a very flexible platform for them. And I think we'll see more of that over the years. Okay, again, in the simplicity of Lego design, let's say I have 4 channels, 2, 3, 4, 5. There is no channel 1. And that's coming to our combiner, and our combiner pretty much gives you out what you got in. So let's say I have 30 dB coming out. So since they're separated by frequency, you're just simply combining those signals, so you have 4 individual frequencies. Let's say I use a tap. And again, I like taps. You'll see that in my designs. And let's say this is a -18 tap. So out of the 30, I'm going to get 12 out of all 8 outputs. And I could easily go well over 100 feet here and output that easily to TVs. So there's 8 TVs at 100 feet, and I could keep on going and going, because the RF output over here is 29, just 1 less. So I could feed that, say, to another group of TVs 400 feet away and continue the design going. Here I have this other splitter, so I've gone 400 foot to this splitter. Now I get one that has subtracting just about 10.5. So now on those 8 TVs, and this is just a splitter, okay, so I'm not doing a tap, and I'm feeding those 8 TVs, and they're getting about 6.5 dB at every TV. The FCC would love you to hit zeros, but I think most of us who design for RF like to be a little bit fat and have 5, 6, 7 dB available, because in a perfect world doesn't exist. Feeds are longer than we planned, and other channels can affect level. But RF is very flexible. My target is going to be like that plus or minus 10 dB. So as long as I'm close, you won't see any difference. So that's the beauty of RF, is you don't have to be exact. You just don't want to have something really, really extremely low, minus 30 dB, minus 40 dB. You don't want to hit TVs with minus 40 dB, because the automatic gain control freaks out. It's just too strong. So a nice balance is good. And over here I'm going to a 2-way splitter. So I've got a bunch of TVs here with just 30 dB, and you can see, because the economy of using splitters and taps, I could keep on going here and have a lot more TVs, and I only started with a small amount of power. So that's the beauty of RF. Your losses over components and distance are fairly minimal, and so it makes for a very flexible design. There's no perfect design, but there's typical ones different guys use for like different situations. So once you get into it, you can start replicating design over and over. As I said before, you can do control over RF. It's very simple. You have one box per TV. It has the codes inside it. So it could be infrared or it could be RS-232. And there's no custom programming. The codes are already in the boxes. You don't have to think about being an AMX, being a Sharp TV or an infrared TV or a Samsung, as you would if you're doing programming in a conventional system. You're sending a generic protocol: power on, power off, channel here, channel there, volume here, input number this, input number that. The actual codes you send to the TV are inside the box. So your programming is very generic. We also have our own software that has presets and web schedules, and everything else are done with pages. So going to my other screen here, come on, give it to me. It's not going to give it to me. I can go to a page that has buttons on it. So you hit a button and all the channels go to, all the TVs or a group of TVs go to a certain channel. I also have control panels, more like sports bar, where somebody would hit 4 or 5 TVs, hit a channel, press the go button, and the TVs go to that channel. Basically, in this software called Display Express, you set up your channel list, you set up the names and addresses of the control boxes in the system, and then you make presets which say, okay, this group of TVs or this TV will do this action when I push the button, or I schedule it. And so in the morning, all the TVs turn on, hallway TVs go to this channel, lobby TVs go to the signage channel, some of the other TVs go to the weather station, and you can have a daily schedule, manage the video throughout the system. And all you had to do is you put the numbers in, say who goes to what, show them as buttons on control panels, put them in schedules, and you're done. And really quickly, there's one box that has a 232 output. Again, the codes are inside. So if it's LG or Samsung, ViewSonic is a new commercial TV, Sunbright, the codes are inside. We already know how to control it. Another box does infrared output. You can select any number of TVs. All the codes are actually inside the box. And then we have a tuner that tunes the channel, but it also does 232 control, and you're going to use that typically for video walls that have monitors or projectors, have no tuners, and so you might have a large casino system that's mainly doing the smaller controllers, and maybe in the sports book and a couple other areas you have some tuners in there to do video wall images. When you integrate, you're going to take either IP commands or 232 commands, or both, and send them this box we call the ICE head end. Inside is going to immediately format that into a microchannel that's between 4 and 5, and it's going to send that out. And you're going to mix that with all the other modulators and channels that are combined within the system. So wherever the RF system goes, our control channel goes as well. So this is whether you're using a control, I've got systems with RTI controllers, Crestron systems, AMX systems going to that. This becomes a control port for it. It only needs one IP port or one 232 port to control thousands of TVs. Or they use the software because the site wants to set up the TVs themselves. They don't want a programmer coming in every time they add a TV. So churches and large sports facilities will use our software because they could add a TV just by typing in the number and giving you the name. On our boxes, the addresses are fairly simple. The first switch is a familiar binary switch, so you're adding 1 and 2 together, turn them on, that's 3. The next switch adds 4, and so on. So you're adding the numbers up to create a number up to 255. And that's a unique number you're assigning to that TV. And then we have multipliers. The second switch, the first switch will say add 256. So in this address, the first number is 3, the next one's 256. So my number for that device is 259. You just add them together. So it's a very simple matter of setting the switches. Because we have the multipliers on these 4 switches, we can do up to 4,000 TVs. So a site that has 1,700 TVs, it's not a problem in our scheme. Plus, you can set a command, all the TVs go on at once, or just a group of TVs goes all at once. You don't have to go bing, 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 bing to 4,000 TVs. You can do it all at the same time. That's it. That's about all you have to know to set up your device numbers. Set up the software, run the RF, you're done. Now, wherever time I have this kind of thing, everybody wants to talk about 4K because you're inundated with 4K from all the guys talking about their routing switchers, IP switchers, and 4K TVs and whatnot. The thing to realize, the view on this is a very different thing for commercial sites, network guys, people who create software and media like Netflix. They're aware of the realities, so they're kind of talking 4K a little bit investor-wise, but they know a couple things that you and I kind of know already, that your eyes cannot perceive 4K in the typical distances and sizes that you have in your home, that you have in a conference room, boardrooms. You can have a marvelous 4K TV there and 4K content, but if it was 1080p, you wouldn't know the difference because your eyes can't see the difference. You do in a theater, but you got a 60-foot screen. So that's why 4K was developed, was for monster screens in theaters. It doesn't necessarily translate to the 60-inch screen in your boardroom or in your house. Also, the marketing for 4K is working very well on TVs because it's a new way of getting a lot more money for the TVs that you're selling. But actually the encoding technology, the decoding technology, and the infrastructure is still in its infancy. I've got more in my blogs that I'll link you to, but we might be 2 years away from actually seeing 4K from Netflix in common usage because the HEVC codec is only slightly more efficient than MPEG-4, and that's not going to cut it to do 4K. You'll also have to remember that latency is going to be huge because you're trying to scrape a 4K video and squeeze it into the same kind of stream that 1080p did. So these are going to take much longer to create that data and shrink that data. So if 500 milliseconds bothers you, wait till 4K. It's going to be much longer. Again, for Netflix, you're not going to notice so much. But for commercial use, you're going to see a difference. Keep your eyes open. I was at CEDA recently, so in a whole bunch of 4K signs and everything else. But what they were really doing is taking 4K, downscaling it down to 1080p, using standard MPEG streams to distribute the content, and then scaling it back up to 4K at the display. Not really the concept we're talking about. Most of the display manufacturers tell us, please just keep it 1080p. We know how to scale it for our TV. When I do scaling it and downscaling and upscaling it, then there's other artifacts and things we have to cope with, and it may not be optimal in the system. So some of the blog talks and things I was talking about, and you might have picked up on, are go to our website at contemporaryresearch.com. The shortcut to that is crwww.com. We'll get you to the same place. And there's a search site box on the top right corner. So enter 4K there, and I'll talk more in depth on what's going on with 4K technology and encoding, and links to what Forbes is saying about 4K, that it's not really what you think it is in your front room. Enter QMOD HDMI to find out more input on how to use HDMI and HDCP with anybody's encoder, not just mine. And some suggestions on dealing with that, though most of the times you're not dealing with Blu-ray and protected content, you're dealing with your own content. Or the site is paying to see this content over QAM encoding, and so the content guys already paid and they're happy, and so it's okay to condition HDMI in those cases because you have a contract that says it's okay. DXRF will get you a little basic description of how RF control is integrated in a control system and an RF. CR webinars is another search term. Click on training. This is only one of 2 webinars we have now, and both will get you 1 credit unit for training through Infocom. So if you just take the test at the end of either course, you'll end up getting 2 hours of training. And if you look around the CR blog, we have many more ideas on encoding, decoding, tuners, and other topics that integrators have brought out. So every time us in tech support see topics where people are confused, we write a blog about it and publish that on our site. So go there if you have more ideas. And again, at the end of this video, stay on the page where you launched this video, and if you want to get the credit, just take the short test. There's a link for that. That'll go to us. We'll send you a certificate that you have the training. You can take that to Infocom and get an additional credit for your professional training. Again, thanks for listening to all of this. If you're interested in more information, you have questions, you can send me an email at doug@crwww.com. Call us at 888-972-2728. We're happy to answer your questions. We like systems that work, and we want to make sure you can make it work. Anyhow, good night, and we'll see you in the next webinar.